Hi everyone, today we will start from where we left off yesterday, and we were on a part 1 intro to React, and today we'll start with JavaScript. So JavaScript is basically a programming language, scripting language also, and this is the main core language behind all front-end web development, and even these days back-end web development like uh, Node.js, Dino, Bun, just to name a few runtimes. And if you here purpose of full stack open to teach us JavaScript is just a refresher around JavaScript. Obviously, if we are learning React, we know JavaScript quite bit perfectly. So this is just a refresher around JavaScript, which we'll do, I mean, in at least hour or 2 hours for today. And if there are exercises like these, we will finish these. And just another day, we will start doing or React stuff again. So first core concept of JavaScript is variables, but we'll start by reading from right here. During the course, we have a goal to need to learn sufficient amount of JavaScript in addition to web development. Okay, we need sufficient amount of JavaScript. Okay, JavaScript has advanced rapidly in last few years. In this course, we use features from newer versions. The official name of JavaScript standard is ECMAScript. At this moment, the latest version is one released June 2024 with the name of ECMAScript 2024, otherwise known as ES15. Browsers do not yet support all of the JavaScript newest features. Due to this fact, a lot of code run in browser has been transpiled from newer version of JavaScript to an older version. This is called, I think, polyfilling. Polyfills. I like Babel like stuff, I think. More compatible version. Today, the most popular way to do transpiling using Babel. Transpilation is automatically configured in React application created by Vite. We will take a closer look at a configuration and transpilation in part 7 of the course. Okay, Node.js is JavaScript runtime environment based on Google's V8 JavaScript engine and works practically anywhere from servers to mobile phones. Let's practice writing some JavaScript using Node. The latest version of Node is already understand the latest version of JavaScript. Okay, so code does not need to be transpiled. The code is written into files ending with .js and that are run by issuing command node name of file.js. Okay. It's also possible to write JavaScript code in a Node.js console. Open by typing node command line like this. Node. Okay, here is the node CLI. I mean, if I do 3 plus 3 will give me 6. Console dot. Yeah, I have to complete right here. Console dot. Hello. It will log. Hello. Yeah, and return undefined. The newest revision of Chrome handles newer feature of JavaScript as well without transpiling the code. Alternatively, you can use tool like JSBin. What is it? It's an online tool for JavaScript transpiling, but not transpiling basically for JavaScript, running a JavaScript or interpreting a JavaScript file. Okay, JavaScript is sort of reinvent what it is, both the name of syntax to Java, but when it comes to the core mechanism of the language, they could not be more different. Coming from Java background, the behavior of JavaScript is seen with alien, especially if if one does not make the effort to look up its features. Okay, enough talk, I think enough. In certain circles, it has been also popular to attempt simulating Java features and design patterns in Java. We do not recommend doing this as a language and respective ecosystem are ultimately very different. In JavaScript, there are a few ways to go about defining variables. Const, let, and var. Three ways. Okay. Var is basically a global scope, and let and const are block scope variables. Okay. I think I should do a refresher about global scope and block scope right now. I think it's a bit older when I learned about these concepts, but I think let's do a little fun. Test.js, okay, touch test.js, test.js, okay, that name is equal to some name, and here is a function, say hi, and yes, it's returning say hi plus name. Okay, pretty weird syntax. I wrote a pretty weird function. If I mean, call say hi, I mean it should log. I don't want to mess. Log. Okay, say hi. Compile this and cd node. Node. No touch on test. Test.js. Oh, what it means. I called say hi right here. Why is printing function? Let's call it again. I'm a bit confused with really simple JavaScript syntax. Oh, inspect. Warning. I mean, bro, that's why I hate little bit red. I mean, warning. Do not paste code in DevTools console you don't understand or haven't reviewed yourself. This could allow attackers to steal your identity or control your computer. Please type of allow pasting. Allow pasting and now paste. Oh. no parents, log console. Hello. I don't know. And what's going on there? I mean, let's say this is part. Really stuff. Why it's making. I mean, I'm calling a function. What's going wrong here? Oh, I'm really ugly person. I'm out of mind right now. I don't know. I mean, I did just say hi plus name. I mean, now it should work as expected. And I mean, this happens when you're super out of one, and when you don't pay attention what you're doing. This happens. Okay, this is, by the way, this is a global scope. We can call it here log in function any. Okay, name. Okay, and if we do this, the cost is printed. But if we define another variable with let name, I'm running out of naming variables. Naming one is equal to some of my brand name, like month, maybe. Yeah. And if I try to log this here, name one, and ah, I should get an error. No, this can be, I mean, accessed because this is in, we declared in global. If we declare in some kind of block, now we'll get an error because this is inside a block. And yeah, this is called block scoping. I mean, if this is inside a function, then also the same thing. So this is a global scope. If we do var name in a block, nothing will happen. Let's say comment out this now, and we run a program, it will work fine. Okay, and this is block scope. I mean, one other concept about scoping, I think I should clear right here for me, is lexical scoping. I mean, lexical scoping is kind of scoping like if there is a function and okay, let's create another new function. A function do meal, do meal, okay, and in do meal, yeah, let be declared let cat name is equal to some cat, not a variable, so some cat, and I have another function inside a function. What should cat do to meow? Meow, meow. Let's log and cat name does meow, meow. Okay. Now if we call this Mio right here, look, I mean if I call do Mio right here and we run, anyone is undefined some above error. Okay, this will not work because name one is block code variable. Okay, if I do mail right now and cats does some mail. By the way, this is right here, but we can access it here. Whether it's a lock scope, it can be accessed from one from this function's memory right here. This function variable inside this. And also this is called I think closure, some kind of, but if we declare some variable like let some some var is equal to hello, okay, we cannot call some var right here. I mean, we will get an error right now. Okay, we got an error. So this is a lexical scoping, I think. Yeah, and also this is, I don't know, this is also called closure or not. I mean, closure is basically I think a function remembers uh, this function will remember this variable or this function's memory even this function executed and destroyed. I think, I mean, let me check closure. I mean, I forgot closure. Yeah, I mean, I think this is a closure. Good, good, good. What do you call about closure? Yeah, this is a local variable created by init and display name. User variable declared in a parent function. Okay, display name init. Yeah, this is lexical scoping. Okay, scoping with Latin const. Okay, then where is closure? Closure right here. Consider following code example: function some name and name this return. Okay, when we return this display name somewhere else, and when we call this and here right here, this function has a memory of this. Okay, should I read this or it will be boring and tiring? I mean, I know what is closure, and when I need to know, I'll get it back. Right now, this is enough, I think. What is closure? Little small refresher around closure for me. Okay, so we did a variable. What's const? It's create constant for variable uh, if it's a let remove these for now. If it's a let, I can do name one is equal to some other name. Okay, it will work fine right now. It will work fine. If this is, by the way, if this is const, the const, then if I run, I will get an error because constant cannot be reassigned. Okay, assignment to constant variables it cannot be reassigned. So we cannot perform this action. If we want to perform this action, we must need to have a where, by the way, where is discouraged using because it's create global scope variable which is available around all programs, so we should not use where. the common practice is Latin const. Okay, that's it. Let's go now. Skip all of this because we got it. And Latin const came in ES 2015, which is also called ES6. Okay, and then data structures. I mean, YouTube. Who is this? Okay, my God.
Good Monday morning.
One function. I'm 8 years old video, but I listened. I watched his couple of videos. He's a really good guy. Let's leave him for right now. An array and a couple of examples used. I mean, array is a data structures like in Python they have lists, and in C also arrays. So this is an array, and we can push, we can slice, we can loop over an array using for each or map, for off, for in. I think loop, couple of loops. I think I don't need to uh, demonstrate this on a code. Notable this example, in fact, okay, if yeah, that's great. If even arrays are declared via const, they can be modified with this push and I mean pull. I think no, not pull. I think a couple of array methods like pushing or popping out arrays, items for arrays. Though so the const does not make arrays immutable. Arrays are still mutable. Okay. I mean, why? I mean, this is the case because arrays are, I think, reference data types, non-primitives, and I think that's why, or maybe some other reason, some design choice by JavaScript, ECMAScript team. Okay, but the point to remember is const does not make arrays immutable. They are still mutable. We can mutate, we can copy, we can push items, pop items, anything we can do with arrays. Okay. Notable in this example, the fact although variables declared const cannot be reassigned. It means they are immutable for different values. The constant of the object its references can still be modified. This is because const declaration ensures immutability of reference itself. Okay, I mean, if we declare a variable, it creates a reference in a memory, and one reference still connected or assigned to one variable. But if we declare array which is non-primitive data type, and then something different happen. I mean, okay, now the data points. Okay, when we are, I mean, when we are creating one variable, it's connected a reference to one memory location in program memory location. So when we try to change, the variable is tightly coupled with the memory location. But in case of non-primitive data types, which are not more than ones, like arrays have more than ones or even one, then also this is a different scenario for a program to handle it. Think of it like changing a furniture inside a house while address of the house remains same. One way of iterating through items and for each as an example. This is pretty cool, I think. In previous example, a new item was added a push when using React techniques. Functional programming are used using characteristic functions rather than use immutable data structures. Okay, what are these? In React code, is it preferable to use method concat? Let's see this, which creates new array to added item. This ensures original array remains unchanged. Okay, these two things I will see them later, but right now I want to see why. I want to see why. I mean, why not make variables immutable, but uh, uh, I mean primitive data types immutable, but non-primitive stay mutable. I mean, let's question to DeepSeek. Why const make non-primitive data types immutable while primitive? Maybe making silly mistakes today. While non-primitives stay even we use const with them in JavaScript. Okay, spelling mistakes are go deep. No, no, not go deep. It's already going deep. Array.prototype.concat. We will see immutability. I mean, we'll see it later, but for now, these are arrays. Concat, we will see it. We will see it later. Okay. The method called t.contact5 concat does not add a new item old array, but returns a new array which besides containing items of old array, it contains a new item. There are plenty of useful methods defined for arrays using map. We can map over them, okay. I mean, I want to really learn more about immutability first, and second, I mean, how immutability plays a great role in React functional programming and React code. I mean, React philosophy. Based on our array, map returns creates a new array, which for which functions given for which the function given as a parameter is used to create the items. In this case, for example, the original value of multiplied by 2, okay, and we got this. Map can also transform array into something completely different. Okay, here an array field with the integer values transform into array containing string of HTML map. Noted part 2 of this course we will see map using quite frequently in React. Yes, individual items of array easy to assign to a variables with the help of destructuring. Yeah, we can get first, second, do destructuring. Array destructuring is bit, I think, cool, and also same way object destructuring happen. Just we need to use curly braces right here. Let's hit up DeepSeek back after hit before just before going to objects. above variable first is assigned. I know this. I'm not a kid. In JavaScript, const keyword ensures variable and identifier cannot be reassigned, but it does not make the value itself, the behavior defines itself immutable. Okay, reassignment and immutability are completely different thing. It means these are immutable by nature. Number, okay, symbol are stored in by value, stored by value and stored by reference. Okay, when declared const, we cannot reassign. I mean, stored by value and stored by reference are, I think, I mean, stored by value is that the primitive data type value is completely intact and connected with a memory location in with the memory location, and stored by reference is the data is I think referenced to a memory location, and it can be made be changed. I mean, I want to be clear at this later. I mean, I think I should know. Store by value versus store by reference. What difference? I mean, these are immutable by nature. Const doesn't make them immutable. It means var can also be immutable. Immutability, what immutability mean? Immutability mean when we reassign same variable name to another value, the old value got vanished or destroyed or whatever. I mean, what is immutability? I mean, yeah. What it means, the actual value is stored directly in variable's memory location. Like, this is 0000236 SSS HHJJ3D. This is memory location, and the value of, let's say, var hello, var name is equal to vakas, and this vakas, I mean, this vakas is, I think, saved right here in this memory location. Okay, I got it. Okay, directly, I mean, this is uh, stored by value. Okay, now let's see stored by reference. I mean, number, primitive data types, number, string, boolean, null, undefined, symbol, big int. When we assign primitive variables to another variable, uh, sorry, when you assign a primitive variable to another variable, copy of the value is created. Modifying the copied variable does not affect original variable. Okay. I mean, when we copy, let a is equal to 10, and when we do b is equal to a, it's not referencing to the same memory, but it's creating its own memory. Let's copy this and come up here and copy this. Okay. Now let a is equal to 10. Let's copy this first. I mean, this will get this A will get its own copy of, let's say I want to copy this, but this isn't gonna be the same. It's gonna be a bit different. This is a memory location. When we do let b is equal to a, it really doesn't mean it reference the same memory location and got value by from here. Okay, this 10. No, this does not mean. In case of primitive types, it creates a copy of this value to a new, completely brand new memory location. Okay, new memory location, its own memory location. Okay, let's say this is a bit different. Okay, now if we do 8 is equal to 20. Okay, if we do a is equal to 20, a is equal to 20, this will just affect this guy, not this memory location. This is changed, but b is equal to a is completely different copy, so this change will not affect this one. Okay, so this is stored by, I think, value. Okay, I mean, we got it. And stored by reference is gonna be a complete opposite. Stored by reference, okay, let's do a store by reference. I think we also should examine this store by reference thing. It would be really cool. If I try to copy this and run, let's object1 name is equal to alias, object2 is equal to object1. Okay, if I change object1 name modified, name this guy, and object2 does name, this is also changed. Okay, let's go through diagramming for better sense. Let's say object1, we declared an object1 variable. This got some memory location. Okay, this got some memory location, this variable. Okay, some different one. Okay, this got some memory location, but when we do let object 2 is equal to obj1 in non-primitive, because this is a non-primitive data type, we'll get a reference to the same memory location. And when we will change, we'll change obj1 dot name is equal to something else like Bob right here. This will affect this guy and also affect this variable. Okay, affect both. Complete opposite of by store by reference. Okay, and store by value. I think I don't need this, but we need this later maybe. Store by value. Okay, this is stored by value and stored by, okay, Non-primitive types, objects, arrays, and functions are stored by reference. Okay, same object in memory. Okay, key implications, primitives copies values, points to same array, equality check, compare values, false different objects. Okay, I got it. Function or passed by value. Primitives are lightweight and immutable. Okay. What was- Okay, we got the answer why. I mean, what is immutability or mutability? What is what is immutability? Because we can reassign primitives while they are called immutable. Immutable. Okay. Objects and functions. Okay, user is confused about primitive data types called immutable, even though we can reassign variable by holding. I mean, okay. This is a common point of confusion. Let's clarify immutability and why primitives are called immutable, even though variables holding them can be reassigned. The key lies in distinguishing between variables and values. Okay. Immutability is not equal to reassignment. Okay. Immutability refers whether a value itself can be changed after it's created. Reassignment values can point to a new value. Primitives are immutable by nature, but variables holding a primitive can still be reassigned unless declared with a const. Okay, let str is equal to word. What's immutable? The string hello itself. You cannot modify individual characters. It's time. Let's try this now. So, okay, how do I can see, I mean, what's happening in memory right now? I can't, but let's go little by little like this. Well, silently, strings are immutable. str at 1, let's give it a completely different word so we can really experience the difference. You, okay, tr is still same. This assignment does not mutate the original str. Okay, reassignment is not equal to when we reassign str to word, you're replacing reference in. I mean, let's go to xcode draw and check it. I mean, let's go to copy a program. Where am I? Copy a program. Let str is equal to hello. Okay, there is a memory location. Let's say 555 HHTT. Okay, this is a memory location, and this holds a word hello. Okay, this hello string. Okay, and what we did, we declared let str is equal to hello. By the way, hello is right here, so str is equal to this memory location. Okay, got it. Str is equal to this memory location. Then we change our mind and say, hey, str is now equal to word. Word. Okay. So word will not replace hello and stored right here, but word will have its own memory location like different, and str will just start pointing this str will just start pointing to this instead of this. Okay, the better way to demonstrate this, I mean, removing couple of this arrow, and I mean this will start pointing. I mean, I can't really do, but yeah, this way. This will start pointing. I mean, first when we do this, this will start pointing right here. I mean, hello. And when we reassign str is equal to word, this same str start pointing to here. Okay, this is a difference. Okay, okay, I think. Hmm, let's revive again. When variable is the same, variable is the same. Okay, str is equal to word. We declare this, then this variable will start pointing to here. Okay, but in case of object we saw earlier, when we change this, I mean, the data got changed on a same memory location. There's a no pointing here and there, but right here. I mean, if we little bit clear this, I mean, oh boy, let's clear this little bit. I mean, for better understanding, I mean, we need to cut this and paste it right here. Okay, and now this is stored right here. Okay, and we what we did, we do let object is equal to this. So object will start pointing here. Then we say let object 2 is equal to object 1. This will again, this also will start pointing here. And when we do object 1 dot name is equal to Bob. Okay, object 1 dot name this is equal to Bob this. Okay, so this will change value of name right here, and both of them take effect from a same memory location. But in case of this, I mean, this will change completely point to some different memory location. Okay, this is immutability. Okay, this is a complete clear immutability. Mutable, I mean mutable, like, okay, mutable. Let's do mutable stuff. Like this is a program. Const array is equal to this is this. Okay, let's bring this here, and I'm gonna separate this out, cut this, and paste it somewhere else. This data structure is stored on some memory location like this, and we do const arr is equal to this, so this will start pointing right here. Okay, then we do arr dot push. It really changes data on this address rather than creating a new array and mutating, adding a data into it, copying this and adding on a new memory address. But it will mutate this, and when we do this, this log is pointing to a same memory location. Okay, this is mutable because it's changing on the same memory location. Okay, we got a mutability and immutability now. Immutability is about values, not variables. Okay, values right here, look at here, values are on a completely different memory locations, and in immutability. But in mutability, values stay on the same memory location, and uh, variables start pointing to a same memory location. Let's do little example and then go away from here. Let a is equal to 5, a is equal to 10. Okay, this same story again. This is on a different memory location. 5, the value 5 is, and the 10 is on different. But a, this is the same memory location, and this will do a mutation on a same memory location. Okay, immutability has unintended side effects. Immutability, I know it's a huge topic. It's really preferred in React ecosystem, or functional programming ecosystem. I think I should spend hundreds of hours to practicing and really getting good at immutability and immutable data structures. But right now, this enough understanding of immutability is enough. Okay, my Pomodoro alarms. Skip the break and start again. Okay, so now we know immutability, why primitives are immutable, and how what immutability means, and how they are immutable primitives, and why non-primitives are mutable, and how they work, how they are saved in memory addresses, this and that and whatnot. And now we can move to objects. There are a few different ways of defining objects in JavaScript. One way common method is using literals, which happens by listing its properties within braces, like this, or like this, or like this. Okay. The value of the properties can be any type. I mean, it can be arrays, primitives, non-primitives, and might be functions also. Okay. I mean, functions also. This little bit knocked my head. I mean, can I really do, I mean, define a function? It, then it will be called a method. I mean, this is common OOP practice, but why not start doing here? Oh boy. Mhm. And this, that's why I hate consoles a lot these days. I mean, function like this, say hello, log, say hello. I mean, we can define a function object 2 dot say hello. Uh-oh, say hello, and we're good to go. We can run this and it will say hello. I mean, really quickest way to examine stuff. Okay. I mean, objects are also mutable data structures. We can mutate them. It really means in memory, nothing to reassignment or nothing to doing these things. Okay. I mean, we can access object properties by dot or by this. Okay, this way. And this is useful when we cannot do this. Like sometimes this happens. So we have methods, we did it. You define object on. Object can also be defined using so-called constructor functions. Okay, and classes and OOP stuff. We will dig to OOP really later. After full stack open, I have plans to really dig deeper in OOP and FP both for at least 15 days, spending really 3 to 4 hours per day to understanding OOP. Might be really playing with OOP language like Java and FP language like Haskell or Elixir or OCaml maybe. I mean, some cool functional programming language also. I mean, I want to really, I mean, taste both paradigms. I mean, later I have plans in 2025, end of 2025 maybe, or in the mid. Functions, we already became familiar with the defining arrow function. The complete process is this. Okay, function is like a black box which takes input, return as output. Okay, and inside this, this do processing, some kind of processing and giving us back uh, output. Okay, really core idea. This is taking input, returning output. This is function. Okay, there are some syntax associated with functions. We can do this way, we can do function way, we can do function. This is also called function expression and arrow function. I mean, defining this way. I mean, you can see on MDN. I think this is not super I think useful for now. I mean, function declaration, we can declare this way and we can declare expression way. This is okay. I mean, expressions, I think not used, used, or I think, I mean, Houston, I forgot Houston right now. I think, I know Houston, how it works. Lately, I learned about this, but yeah, I think function expressions are not used, but functions are used. Our functions are not used and function expressions are used. I mean, vice versa. I should check it out. I think used thing. I even got spellings. Sting in Java. Script. Okay, I mean function expression. I mean we continue building the application that we started working on previous exercises. You can write a code into same project. Since we are only interested in final state of submitted pro tip, you may run into issues while coming to structured props. A good way to making things more clear, printing the props to uh, what's going on. 1.3. Okay, this is not a JavaScript exercise. This is still a React exercise. Okay, 1.4. Okay, let's skip exercises for now. I mean, we will do exercises a bit later after completing this section. Object method and this. I mean, they are teaching whole JavaScript in same day. I mean, this is bit overwhelming. Because of this course uses version of React containing React hooks, we do not need to define objects and methods. The contents of this chapter are not relevant to the course, but are certainly may need be good to know. In particular, when using older version of React, one must understand the topics of this chapter. Arrow functions and function defined using function keyword. Now, keywords vary substantially when it comes to how they behave with the respect to keyword this, which refers to object itself when we assign a method properties that are functions. Okay, this means this object. This always means to its context where this is called. Okay. Classes in JavaScript material. I mean, classes syntactic figure around prototypical way of defining doing OOP in JavaScript. Okay, and this is it. As mentioned previously, there are no classes mechanism in JavaScript. One in object-oriented programming. There are, however, features that make simulating OOP classes possible. Let's take a quick look at classes syntax in JavaScript. ES6 substantially simplifies the definition of classes or class-like thing in JavaScript. In following example, we define class called person and two person objects. Okay, let's go. I mean, we'll do exercises and then we are good to go, I think. There's a huge this keyword document. I think I should read after doing after doing exercises, I think. Function context. Yes, after this. Concatenate immutability, I got it. Oh, what we did. He used thing. Declare, he used it and initialize and define. I mean, this is another day topic. I mean, Houston is a pretty vast topic. Some other day we will explore, and this also. I mean, right now we don't need. I mean, we are learning React, not JavaScript. This was a really bit small refresher. So exercise 1.3. Let's move forward to using objects in our application. Modify variable definitions of app component. This follows allow also refactor of application, so that still works. Okay, we are in there. We are here, and let's kill this one. And npm npm run dev. We did it. I mean, delete this guy. Not delete. Mm. App part 1, part 2, part 3. Create objects of part 1, part 2, part 3. Right now what it is. Part 1. Okay. We will do this. And name is exercise. We done this. We need now commas, not semicolons. Expect. We don't need this now. Okay. Same for part 2. Name is equal to as remove equals to the remove first. Okay. And same for this one. The name is this way. This way and this. Okay. Now we will do uh, after doing this okay, we will do more modification. But for now, this is it, and we wanna make part 1 dot name, part 2 dot name, part 3 dot name, and part 1 dot part 2 dot 3 dot. Okay, copy all of these and paste them right here, and we are good to go. Now, yes. Now let's push this small exercise git and git but it is exercise 1.3 exercise 1.3 completed 1.3. This was 1.3 obviously. Yes, git push. Yes, it's pushed. Now let's do more. I mean, yes, more refactoring. I mean, now we'll do this. Const parts is equal to some array, and we will first of all delete this parts thing and copy all of these and fit here. Just all of them are here. Yes, we don't need these things. Mm, okay. Okay, now content need what? Part 1, part 2, part 3. Messed up. Things are messed up. I think I should do what? First, find out all of this code of I mean, what we wanna achieve. Hmm. Content is content need this. I think. Let's read. Name and exercises. Name and exercises. Okay. Name and exercises. Okay, we can do this. I mean, instead of sending all of this, we can do parts is equal to parts, and when we go in here, we'll not do this, but we'll do parts. And yes, let's kill this. And I mean, first of all, let's log parts. And now part 1. This is creating a pretty complex data structures. I mean, now we need part 1 is parts at 0 dot part at 0 dot name dot name and parts at 0 dot exercise parts at 1 dot name and parts two. Can I loop over this and do stuff? Maybe. Let's do manual way first, then we'll do looping stuff. Parts at one dot name. We'll check parts at one dot date and parts at two. Parts at two dot part three. Parts at two dot exercise three. Okay. No, what's wrong? For now, let's forget total. And application should be working fine. Why it's not? The reading name. Okay. I should do this. Stack development. Stack development. What's wrong happening? What's wrong happening? Name. Object. What's going wrong? What's going wrong? What's going wrong? I mean, parts dot parts maybe. Okay, I did a wrong thing. Props. Here now. Props that part. No, it will be. mm, mm. Data is coming via props. We can do props. Mm, Let's do this and now. Not this and let's remove all of this now. Okay, and log props for now. Parts. Okay, then do props dot part cross dot parts and props. Why not do this on part is equal to props and now to do what? We can do right here also destructing. Okay, we got it. Now here we'll have one more guy, total. I will send him also parts is equal to parts
parts, and we gonna send our total exercises. Total cost total. mm, I mean parts at 0 dot exercise 1, parts at 1 dot exercise 1, and parts at 2 dot exercise 1. I think this is it. This is it. I think this is it. Yes, this is it. Okay, there are no need to go through arrays using Google. We will come back to topic rendering components. Okay, we are not. I mean, there was no solution to doing looping right here. I mean, how it is. There is a one way to do array dot reduce and take all of this, adding all of this, but this is not super useful right here. This is the last 1.3 and 1.4. No, we did 1.4. Okay, exercise 1.4 we did. I need to git add git 1.4 is completed and git push. No, in 1.5 we'll do one more step. We'll do this and this and this and this and oh, and this, and we'll remove this code const, and I think uh, yes, const goes here. Const is equal to this and parts is equal to this. Okay, let's copy this and paste this right here. And now course dot name course dot name and course dot parts and course dot parts, and that's it. I think another exercise is done. Let's check it. Is this enough? Yeah. Let's push 1.5 and let's git add 1.5 push. I mean, we completed 3 exercises and pushed them successfully, and so or uh, you didn't know JS. This is a really cool book series, and I will take a time to read both of these. Hmm. They're self-published and masters. I don't want to buy this. These really need for what is this going on? Okay, we can read free these books, I think. I mean, I'll find them when I need to read. I know enough there, I think. So let's go to component state and this and this. I mean, we completed previous lecture and I think I should see time, how much time I spend. If it's above 2 hours, I should stop right now because enough, maybe 1 hour 26 minutes. I should keep going. I mean, we'll not do exercises or anything. We'll just do a little bit brainstorming about this and then we will go. I mean, we will dive deeper tomorrow on this, but let's little bit read and little bit go through material how much we can in next 20 to 30 minutes. So this is part C, component state event handler. Let's go back working with React. Okay, we start with a new example. Const hello is equal to props. We know what props are. Mm. Return props are name, props are date, years old. Okay, we provided name and age from here and greeting hello 26 plus 1. Okay, go. Component helper function. By the way, I'm tired right now and I'm gonna stop this. I'm gonna stop this for now and tomorrow we'll start from this. I mean, I'm not really feeling fresh right now to study more. And this is enough for today. Tomorrow we'll start from new section with a new energy and we'll hopefully we'll complete all of this tomorrow. Goodbye. Bye bye.